Assalamualaikum, hi, good day. My name is Anuar bin Pawan, currently enrolling for CEEC 950 PhD in Civil Engineering. Today, I would like to update my research progress throughout my 9th semester. This is the overview of my research progress presentation. The item 1 to 4 is about research candidate and brief information about my research, followed by item 5 about major milestone on the research, then item 6, the timeline, item 7, status of publication, item 8, status of thesis writing, and finally item 9 is the planning for the next semester. About student information, my name is Anuar bin Pawan. My student ID is 2017473466 under the Civil Engineering PhD program CEEC 950. Prior to joining this program, I worked as a mechanical engineer in the Department of Railways, Regulatory Division under the Ministry of Transport from December 2005 to April 2009. Following that, I pursued my master degree in Railway System Engineering and Integration at the University of Birmingham, UK. Upon completing my master degree, I was assigned as a senior mechanical engineer at the Public Works Department, JKR Land Transport Division under the Ministry of Works. In September 2017, I commenced my PhD study at the University Technology Umara, Shah Alam. In October 2022, I am assigned as a site officer to supervise Hospital Tuanku Jaafar M&E system upgrading works and have to travel between Shah Alam and Seraman almost every day in order to keep the project running. My research main supervisor is Engineer Technologist Dr. Anizahiyati binti Ali Sibramolisi, supported by two co-supervisors. My first co-supervisor is Professor Madya Technologist Dr. Zuraida binti Saleh from Faculty of Mechanical Engineering UiTM Shah Alam. My second co-supervisor is Professor Madya Technologist Dr. Hajah Norliyati binti Muhammad Amin from Faculty of Civil Engineering UiTM Shah Alam. My research title is Prediction Model Using Fatigue Strength Analysis of Reclaimed Steel Rail Jointing System. There are 5 important terms in this title. The first term is prediction model, which is a process of using known result to create, process and validate, forecast the future outcomes. Second term is fatigue strength analysis or fatigue limit. It's a number of cycles of stress that a sample of a specimen can withstand without failure. Reclaim, as a third keyword here, means a retrieval or recovered material that has been used subject to assessment. The reclaimed material, we must know the background of the samples or specimen, either is recovered from which site. We must have the history of the usage of this retrieved material. The fourth keyword is steel rail. It's a pair of parallel bar made of iron laid on a prepared track. Roadways serve as a guide or a running surface or superstructure of the track system. The final important keyword is jointing system. It's a splice connecting the adjacent end of rails, could be in the form of welded or non-welded type. So in this particular study, jointing system is the welded type. For the title, in short, this research is about developing a predictive model that analyzes known performance to assess a rail weld specific behavior in order to prevent rail breakage. I am now proceed with the introduction to the study. Railway system worldwide has been instrumental in facilitating millions of passenger trips and transporting millions of ton-kilometers of cargo around the world. A critical component of this railway system is the steel rail, which plays a vital role in securing and transferring vertical load to the ground while enduring rigorous rail-wheel interaction. In the diagram on the left, the Q, the vertical load from the axle, is transferring over a wheel at a single contact patch. In this example, the axle load is 200 kilonewton, transferring half of the load to two wheels, which is transferring 100 kilonewton at each wheel over a small contact patch area of 1 centimeter squared. This is very high stress experienced by a small area, which is around 100 kilonewton per centimeter squared, which is equivalent to almost 10,000 bars. The remaining portion of the load is subsequently transferred to the wider surface of the layer after the rail, which is the rail pad, the base plate, the sleepers, the ballast, and to the substructures underneath. Some railways has been used from its initiation of the project to the end of its life, which is very useful. But some of the railways has been used temporarily, has been recovered early for line upgradings, and still retaining plenty of useful life. For example, we have our Malaysian experience, Ipoh Padang Besar single line upgrading works, which only used for less than 3 years for 330 kilometer track. At that time, the usage of the rail was around 17,000 tons, and it is worth around 54 million of steel. This is some kind of good strategy that taken by our government to reuse this reclaimed rail for another project. We have another example, which is a Klang double track KVDT. It's a route from KL station to Klang, Salak South to Seremban, and Simpang Port to Port Klang. This track is about 260 kilometer. The steel itself is around 28,000 ton, and the price of the steel is around 84 million. It operates in 1995 and experiencing rehabilitation works in 2016, only after 22 years of operation. So there are still pending decision either to use or to recycle the steel rail from this project. Some railway lines remain in operation until the end of their designated service life. For example, a 20-ton railway lines has been in service for 30 years, can be reutilized to lower tonnage line in between 10 to 13 ton, as steel has very unique characteristic. It has the indefinite service life and the lower stress limit. So how safe are these reclaimed rails? It requires aid or tools to predict the performance of the fatigue life in order to make sure the welded joints are safe for train operation. Item number 5 shows major milestone of my research. Out of 7 items, 3 of them already agreed without changes. These are the problem statement, objective, and scope of studies. Meanwhile, 4th items require review and further expansion for thesis write-up, which are on the prediction model and remodel improvement. Another items that are still work in progress are the literature review, data analysis, finite modeling, finite element modeling to simplify input-output model for comparison to the industry. The following slides are the major research milestones in a brief coverage. What are the issues in these studies? The issues is the use of reclaimed rails in the railway track. Some of the railway track definitely cannot be used, but most of them are serviceable track material. For example, in 1 kilometer track, there are about 8 weld joints, and this joint need to be proved either it is usable or not. How is this issue of using reclaimed rails become a problem? Reclaimed rails has been perceived as a not good material. This has been discarded and perceived as a high risk due to unknown conditions. In the UK, it has considered as low safety performance. So most of these reclaimed rails are being recycled. There also another approach in the European railways, where the Switzerland railway reused more than 30% of track materials after assessment, and most of them are still serviceable. Malaysian Railways donated our track from Ipoh to Padang Besar for Singapore Kunming lines, and it is still serviceable. Welded joint in reclaimed rails has been cut and replaced with a new rail. Some of the standard really avoid using reclaimed rails welded joint, and this is considered a wastage of 2 to 5% of material, and it requires additional welding process to rejoin this cut rail. There are 4 problems when considering to use reclaimed rails. First, rail weld or rail joint defects are main contributor to rail accidents. Second, welded rail defects are difficult to identify. Third, there are abundance of rail that has been used temporarily, and there are also some rails that has been retired due to line upgrading. And the fourth issues of using reclaimed rails is the track maintenance issues. The first problem when considering to reuse the reclaimed rails is we need to understand the rail defects. In study by Liu of about trail derailment in the US for 10 years from 2000 to 2010 has come out with this statistical data. Broken rail occurrences and broken weld bed has more than 50% than the average of occurrences. In terms of frequent, the broken rail and other defects recorded almost 9 times higher than average of other defects. So based on this statistical data, the broken rails or broken weld dominate both severity and frequency of rail defects in the US. On the second problem statement, welded rail defects are difficult to identify. Rail has 3 distinctive parts: the head, the web, and the foot. For typical UIC rail of modern rail, the head thickness is around 50 mm, the web thickness is about 16 mm, and the foot is 144 mm wide. The ultrasonic detection or transducer requires 3 different angles, 70 degrees, 40 degrees, and 0 degree to penetrate the whole rail, and requires skilled worker to interpret the results. And its process is very slow and time consuming. So this is the defects that occurred at the weld joint, weld bed, and most of these need to be analyzed using the ultrasonic inspection machine. The third problem when considering reusing of railways reclaimed rails is when we are considering to use the early retired rail due to upgrading or temporary use. The trend in the world is changing towards using more higher carrying capacity. So since inception of railways, operator has desired to increase their load carrying capacity from early days 40 tons, then increased to 80 tons, and now in the US they are carrying about 180 ton payloads. So this is increased about more than 400% carrying capacity from the inception. To reuse this steel rail, we need to do the assessment. The fourth problem regarding reuse of the steel rail material, the maintenance of the track itself requires a major undertaking. It requires full scale of machinery, workers, and spares in order to make sure the line is always in operation and operable. There is also required to do the regular rail grinding to minimize the formation of surface crack. Then also require to do the very important checking, internal crack inspection using ultrasonic machine. So the use of reclaimed rails need to be supported by tools or basis in order to understand and the remaining life of the steel before it can be reused again. There are 5 objectives in this study. First, to analyze the fatigue stress of steel rail. Second, to determine fatigue life of reclaimed steel rail joint. Third, to establish relationship between fatigue life at rail joint. Fourth, to establish prediction model based on performance of residual strength. And finally, the study going to establish the fracture control plan using numerical analysis of reclaimed rail joint to deter or to minimize rail joint breakage from occurrences. For the scope of study, the research going to perform the experimental investigation on welded joint. There are 2 areas under study, which is mechanical properties such as the chemical analysis, surface analysis. The second approach is on the mechanical performance of the welded joint, such as bending, fatigue performance of parent rail and welded joint. Second scope of study is to study the crack analysis for its initiation and propagation of failure using scanning electron microscopy. Third scope of study is to assess welded joint strength based on microscopic analysis and empirical formula for trend in fatigue development, failure occurrences, and relationship with fatigue. The fourth scope of study is to model the residual strength using numerical analysis and validate them with experimental data. The final scope of study is to establish fracture control plan for rail operation throughout the rail life cycle in order to minimize the failure. We need to have the train schedule, train type, train loading, train speeds in order to come to this, and this can be obtained from the railway operation. There are also limitations of this study. We have quite a limited number of samples and it has to be optimized. And second limitation, we have limited access to laboratory that capable to perform required tests according to proper standard. And it is a very considerable long lead time to perform a cyclic load test in order to get a full range of limit. On the literature review, there are many references in relation to the defects of welded rails and surface crack initiation. Farhangi and Mousavizadeh 2007 conclude, even though flush butt welding is superior in quality compared to aluminum thermal, flush butt welding still has failure issue due to horizontal split fracture. A second reading is about Sarna and Lansu 2004, found that even though the flush butt welding failure is low at 7.9%, most of the study found the underlying surface crack removal will cause the crack to propagate. So if we don't remove the crack underlying, it's going to propagate and contribute to the rail breakage. Ekberg and Cabo in experimental review observed subsurface initiated rolling contact fatigue occur because of high dynamic contact pressure and the material defect in both welds and the rails. The slow growing defects occur in both foot and the web. Popovic et al. 2014 emphasized the trend of uncontrolled defect which can threaten the traffic safety, increases rail maintenance, and can lead to the premature removal of rails or even the worst case scenario, complete rail failure. Vescovic 2012 outlined surface crack happens during rolling contact fatigue and plastic flow due to high stress at surface area, a small surface area. Furthermore, operation-induced factors such as train speed, axial load, traffic density, and poor maintenance regime plays important roles to the propagation of the. The author has referred some literature review on use of reclaimed materials. Brinkover in 2012 mentioned that the reclaimed rail can be used as relay inserts and closures. American railway standards also mention that reused rail must follow the standards and it need to be used according to its previous function. The straight track need to be used at the straight track and the curve must be at the curve. The Rail Council 2008 mentioned that in the UK it is not a common practice, but in the Switzerland it is been widely heavy industry for reuse of the reclaimed materials. On the prediction techniques, the author has extended additional review on the prediction. As per analysis shall not lack of dependence from loading and specimen geometry. It is suggested by Miner using his literature in 1945, and G. Ayub et al. 2010 and Suresh 1991 agrees on the application rules of linear cumulative shall extend to continuum damage mechanics. So this model need to be associated with the finite element modeling, which was not included in my previous model. So addition to that, the Jagbel 2004 also need to include the multi-axial loading, and railhead experience lateral and vertical deflection including rotation also need between. So this is the improvised version of my model then that has been done throughout this semester. For the conceptual framework of this study, there are two inputs required: experimental data acquisition from the experiment and numerical analysis from the modeling. Both are compared and validate for results, and then this output of welded joint are going to be optimized using all the nodes and the boundaries, and then this input will be apply on the operational load and quantum damage mechanics function, and then we are going to perform updated finite element analysis, and then we're going to simplify the input-output model for fracture control plan. So this is the flowchart of the methodology from the experimental data compared with the numerical analysis, and then the model going to be subjected to the loading from the actual rail. Then if the values are within the range from the experimental, so the data is validated, and further data comparison will be done from the actual train loading from the railway industry. So I'll go briefly on the methodology. There will be 4 major tasks: document and reference study, experimental work, numerical analysis, and development of prediction model and fracture control plan. On the document and reference study, previous studies and gap analysis are performed, and then we are going to perform the welding. We are going to analyze the welding procedure at site, and then we are going to study the history of recovered material usage from the user. The laboratory works for mechanical properties and of welded rails, such as a bending test and rail fatigue test. This is the rail weld fatigue test, which is unfortunately we don't have the system here, but then we are going to change it to a different or similar mechanism. Another mechanical properties tests such as hardness test and macro and micro examination, chemical composition test and tensile pull test to validate the data, third task is numerical analysis. We are going to put all the profile for each rails and subject to the nodes and boundary conditions. This is going to be calibrated further for best results. The final task is to come up with the predictive model and control plan to introduce the load and damage such as fatigue and crack in weld joints to optimize model to predict fracture. This is going to be simulated over actual train loadings. The train types, the density, the speeds, and the axle load. So all this data will be made simplified for the user to put their information and get the analysis using the simplified system. This is the initial Gantt chart of the study in September 2017, but this chart has been revised due to pandemic and other unforeseen events. This is the revised Gantt chart and the completed tasks. This is my semester 9th of my study. As for now, there are 4 ongoing tasks, which are literature review, data interpretation, and modeling, thesis writing, and to be final submission of my viva. Hopefully, if Allah permit, everything will be completed by early next semester. As per status of publication, there are 3 publications and 1 undergo drafting stage. And for the status of thesis writing, chapter 1 already completed the draft, chapter 2 is almost finished, currently revised on the prediction technique. The methodology, there is no change, but there is some improvement on prediction modeling scenarios. Chapter 4, results and discussion. Additional prediction model is included to put actual data train from the company, railway company, and there is also some input from the industry to include the simplified modeling for input and output for their interpretation, for easy interpretation. And as for conclusion, it will follow after we get a very fruitful input from the result discussion. And finally, for planning for the next semester, everything needs to be completed by next semester. So chapter 1 draft need to be already done. Chapter 2 need to complete by next semester, early next semester. Chapter 3, 4, and 5 will follow through after we complete it. So everything will be completed by next semester around March or April, inshallah. With that remark, I would like to conclude my progress update, and thank you very much.